Okay. So, welcome to the first episode of Mind Matters CoCoSci Talks, and today I'm here with Hanbo. So, just for like a small introduction, maybe could you share a bit about your background, what led you to where you are right now, and maybe especially where you focused on using, like large language models, so like LLMs to study how people think, learn, and make decisions.
Oh, yeah. Thank you, Sophie, for inviting me here. I'm Hanbo Xie. I'm currently a third year PhD, a fourth year PhD student in psychology department in Georgia Tech. So my current background is investigating how humans and AI think and reason in a wide variety complex of tasks. Um, for me, I'm actually using a lot of ways. I also I both use some cognitive science insights and experiments to help understand how AI reasons and functions, especially in cognition. While in the other hand, it's just I try to use AI models to try to help our psychologists and cog scientists to analyze the behavior data, text data, and also to building more powerful predictions and explanations possible. So that's so prior my PhD career, I was a master's student in psychology in the University of Arizona. And prior to that, I was doing research assistant in Peking University in China. So that's kind of my background.
Okay, so that's really impressive. I've seen that you've done a lot with this. So maybe could you please elaborate more on your academic journey? Like more specifically, like what kind of inspired you to like start looking into cognitive science, combining psychology and AI and using LLMs in your research? And overall, like how did your academic journey kind of start? Maybe from high school or like what like sparked your interest?
Oh yeah. So that's a very interesting question. So indeed, I had my high school in China. So in China, there not something I know it's not something like AP class systems like in the US. So it's more like a foundational training, maybe just in Chinese, math, English, and physics, chemistry, or biology, something like that. After that, we had college exams, and I was entering into human resource management uh, major in my undergraduate. But just during the 4 years, I was a little bit confused what I should do and what I want to do for the whole life, or maybe just for the next 10 years. But I finally find that human resource management, is kind of a business course, and it more demonstrates about the efficiency in the management in the organization. But I find that some of the times the theories and the applications are just ignoring how humans should care about themselves. It's not a human centered. So that's just drives me, shifts my interest into caring more about what humans are thinking about, what drives them think like this or like that. So I just became interested in psychology. After that, I ever had an opportunity to have an exchange, overseas exchange experiences in California, UCR, University of California, Riverside. And at that there, I just did my take some psychological classes and also involved in a lab rotation to take into some cognitive psychology uh, experiments. So that just inspired me that, oh, it feels like, oh, we can understand human mind in a kind of like physics way, just like we can understand them with scientific experiments, with uh, their reconstruction. So it's not just purely about just randomly getting what people are thinking about. Yeah. So after that, I just have a mind, determine my mind that I should really strive into a serious career about doing cognitive psychology as my career. But I know it's not enough. It was not enough for my background at that time. So I chose to join Peking University and your lab to do research assistant. So I was there. I was doing something more social cognitions, more like how we can understand how people make a decision and learn from feedback in a group. So, multiple people are interacting together. But inspiring from that project, I'm just more interested in that. people integrating social information, integrating environmental information to help them to make optimal decision. But this is kind of a more fundamental way, just like how humans itself just learn adaptively or just understand the world in a more abstract concept, or maybe just more abstract or generalized way that can make us act very flexibly. So at that time, I decided not to do very social stuff, but more like reinforcement learning stuff. So that's how I encountered my current supervisor, Bob Wilson. He was at that time, I think, in the University of Arizona. Um, but indeed, that was very tricky. But when I entered the lab, Bob told me that I should not do something about reinforcement learning, although he already was an expert in reinforcement learning. And for 10 years, he just do something like we do some behavior experiments, we scan the participant's brain, and we use some mathematical models to model their behaviors and try to find some relationship in the kind of blue signals. But that kind of paradigm is kind of maybe it's not all completely outdated, but it's just like very traditional and classical that Bob has already done for 10 years. But at that time, he was just thinking about why we can just hold people, asking them what they're thinking about, just like think aloud stuff. It's a very traditional stuff. But Bob said, I heard there is something like language model, but it's still as early as 2022. So the ChatGPT has not been invented, and the large language model still is only a very expertized model that's for CS folks, especially for NLP folks. So it's not as widespread as today. But Bob just realized probably language model at that time could help us to do something. So I just take the idea and do the project. And there are a lot of expectations during the road. So we just find the large language model suddenly gets very popular, not only in CS, right, but it's also among the world. People are talking about that. People are using that. And I just feel like, okay, so it seems that the large language model are very iterating very quickly. So I should also keep updating my ideas, my kind of paradigm, understand, analyze, and think a lot. So that's how I come to today's that using it's kind of like keeping pace with how AI technicals develops, so I also try to keep my pace with the most recent techniques. And another coincidence is that, think aloud is more like asking people to speak out their thoughts. So it's more like probing how people reason naturally. And currently a reasoning model in large language model is also very popular. So they ask a model to somehow like think step by step. So it's more like it's also a little bit like asking model to think aloud. So I just find another opportunity that I can bridge actually human think aloud with large language model or machine think aloud into a shared cognitive problem space that I can actually use similar ways to understand each of them, right? So that's why how I shaped my current research interests, that I gradually become that I should be generally interested in how AI and how human reasons. And it's kind of a foundational science principles, but moreover, I'm also interested in how we can borrow insights, paradigms, methods from each side to help us improve our understanding to the other side. Yeah, so that's kind of a little now version of the story of how I
Mm.
come here today.
Okay, yeah. So I see you've mentioned that you've done, a lot of experiments and labs, like I guess more specifically, like looking at trends and using AI to understand humans more. So I guess like what are your thoughts on kind of like the other approach to, I guess, cognitive science of maybe using human psychology to improve AI and maybe its ethics? Because I know you've talked about like how you use AI to understand humans, but what are your thoughts on that?
Oh, yeah. So to elaborate this more specifically, so typically, if you know a little bit about AI history, so at the very earliest, at the time that AI was invented, the concept was invented, it was actually having not only CS folks, but also some psychologists, or maybe we could call them the very anecdotal cognitive scientists. Yeah. So indeed, the cognitive science, the subject itself is not just it's not completely about psychology, although they have some overlap. But for CoCoSci itself, it's about the subject to understand intelligence. So while you understand intelligence, it's not only about human intelligence, but also today is artificial intelligence. So specifically, we could borrow some concepts and uh, paradigms that help us to understand how AI behaves. For example, there are some experiments we can use to evaluate how AI performs. For example, their decision making, their learning, their memory, or their semantic understanding, or their planning. There are a lot of cognitive abilities you can test, and there actually have been a lot of research on this. But also, you can use some not that behavioral part, but maybe some analysis part, maybe just how you manipulate experiments. Previously, you understand how humans do, but you can also manipulate experiments, manipulate prompt. That's how AIs will react to different manipulations. And also, there are some kind of neuroscience parts, just like you can probe the human brain activations, and you can also do some simulation studies, try to destroy or maybe find some cases that there are kind of certain areas were destroyed, and then you can find whether their cognitive functions are kind of destroyed causally or not. But in AI, this is more convenient, right? We can just directly play on the neural network computations, and we can just make them work much stronger or making them lose functions at all. And we can say how the computations can affect the output. So generally, I can say we borrow a lot of experimental ideas, we borrow a lot of analysis ideas, and from cognitive science or more generally psychology and neuroscience to help us understand AI better. But vice versa, there's a lot of my research is calling using AI to understand human better. For example, we use a large language model to analyze think aloud, whether it was impossible 40 years ago when think aloud was initially invented. That is because think aloud is kind of natural language, and previously we only use human labeling. We ask human to rate what do you think of they think aloud or what do you think it's talking about. So it's kind of labor intensive and hard to scale. But currently, we have large language models. We can easily analyze them in seconds. And also, we have quantitative interpretation of think aloud. So for me, that's kind of a great opportunity that we can foster AI techniques to revisit some old paradigms that was ever hindered by the technology constraints at that time. And probably we can get new insights, having more tools, toolkits in our hands, and we can just develop more. And also another line of my research is trying to use some large language model fine-tuning or reinforcement learning fine-tuning methods that we try to use large language model to understand how humans are thinking about, just like we can use large language model to train the model to reason about math problems. Only if we have the correct answers, so the model can be taught the correct answers and try to infer what is the correct chain of thought. Now we just apply the same paradigm, but the optimal object is kind of inferring the correct behavior of human beings in the real participant psychological data we have collected. And then we just try to analyze what the model inferred about how humans think about to produce such behaviors. And this can be kind of a natural language version of kind of explanation about human behavior. And very interestingly, it's just purely coming from the models. We do not input any external data, but the model just train on the behaviors and try to have some thoughts about humans. And we do believe that can kind of a new paradigm to use AI techniques to understand human cognition. Yeah.
So since you talked about, how you use a lot of AI to help you kind of look more into like human decision making. So how do you think, like, what do you think is like the main benefit, since you said using manipulation, like, how do you think LLMs can help us study like human decision making, like way better than like the traditional method of like psychology, like without any AI at all? So what's like one main benefit?
Yeah, the one main benefit I think is prediction part. This is also the most powerful part. There is kind of some most recent research maybe published in Nature that they have fine-tuned a large language model on over 100 psychological tasks on the human data set, and they find that the fine-tuned large language model can outperform in prediction for nearly on all the tasks compared to the best cognitive models that ever was developed by cognitive scientists. So I think the best way, the most visible benefit that we can say is the large language model is a very big neural network model, and it's also pre-trained on vast training data, language data set. So it must be, we can just say that the model can be kind of uh, more knowledgeable than any individual. And whatever you are a graduate student or you are a professor, a model should be more knowledgeable than you, but it can now be trained to have more, accurate predictions. So I can say it's the most, kind of the most powerful point.
So I guess like since you mentioned prediction is like the main benefit, so what do you
Yeah.
think like prediction of like human behavior could be useful for since there's a lot of benefits, but in your like what are your thoughts?
Oh, yeah. So, in my opinion, we can discuss this maybe in two different perspectives. So, one perspective is about science investigation. So, it's more about research. I think if you want to understand a thing better, or if you claim you understand them very well, I think one of the essential conditions is that you should predict the behavior, you should predict some superficial stuff very accurately. Or if you have a beautiful theory, but you can never predict things correctly, so that's just beautiful, right? It's not useful. But truly, prediction is not the only thing that we should care about in the science community, but we should also care about explanation, that how we understand them. So I think the next kind of phase is just trying to make the prediction more transparent. But I know it's kind of a little bit hard, but yeah, I think it's kind of the next step, next phase, and we should do. This is for academia, but for business, I think things are more clear, right? Just like in consumer behaviors, business advertisement are always wanting to predict consumer choices, and they can maximize their profits, or maybe in some strategy or consulting companies, or maybe in some navigation, or maybe in the more sensitive, just like national defense. These predictions can just generate the direct benefits into the specific purpose they are working on. So I guess this kind of AI could also help, real world applications where explanation is not that important, but prediction can really influence real world utility. Yeah.
Mhm. So I guess because we know that, nothing is perfect, but do you think it is possible ever for LLMs to completely, like mimic or analyze human thought processes? Like maybe like being able to create the same strategies and also like furthermore, like in your opinion, what are the biggest limitations of using LLMs? Maybe with like possible like outliers or things like that.
Yeah. So I think for generally, I know a lot of people are talking about AGI, that's where LLMs can really outperform humans in a lot of tasks, or maybe more generally, just like whether it will replace humans in works, will domain the human society or governments. Generally, I don't think LLMs can outperform humans. So
Yeah.
it depends on its nature, right? How it was developed or trained. So large language models are mainly trained on the existing data set we already have in the world on the internet. So whatever can train, so you cannot surpass the overall distribution. So it's just like the best you can do is trying to capture every information, capture every detail that you learn from the data set. But with information beyond the data set, for example, this kind of alien that are both our humans and the large language model ever seen. When it comes, large language model probably will not be able to solve this kind of problem, or don't know how to face with them or how to communicate with them. This is because the aliens, this kind of weird concepts or weird distribution never occurs in their training data set. But I believe humans may have some ability to solve that, because humans can have some transfer learning, just like we always expanding our knowledge, and we always expanding our knowledge, our concepts based on what we have already know. And that's kind of how the society was developed and how the science is advances. So generally, I do believe that AI cannot, the limitations that AI can really not outperform uh, humans. But maybe in other words, but I do think AI does provide a lot of benefits to our daily life, to our academic research. So I do think the better future is kind of like AI and human can kind of co-evolution. That's they learn from each other and they try to get new insight together. But they do have their both strengths and weakness. So I do believe this is kind of more, yeah, my expected future promising.
I guess since you mentioned that you think in general, like ultimately that humans can outperform AI in any case. So have you found, like since you've done a lot of research, right, and you have a lot
Yeah.
of experience, have you found any cases where LLMs are able to like accurately replicate like human cognitive bias, so like kind of like accurately predict like their outputs kind of?
Yeah, it depends on the task. If you just focus on a specific task, just like risky decision making, I do believe that AI can at least be fine-tuned, be trained to perform like humans. This is kind of, the Nature paper I discussed just now. So it's kind of like it can just really behave like humans. And what is weird, it's kind of like actually we have a comment after the Nature paper that we remove some task sensitivity, just like without telling the large language models what the task the person is doing, just simply giving some of the history of the specific participant. The large language model can still very accurately to predict what is going on. So that's kind of beyond our expectation at the very beginning. But this is kind of an implicit bias that even psychologists, cognitive scientists, they design the experiment, but they didn't expect that humans can have a lot of bias, such as they tend to repeat their behaviors or tend to switch. But this is totally irrelevant to the task. But the large language models just capture that very accurately, and even without the task, the large language model can still outperform cognitive models. So this means the large language model already learns some implicit bias, and our psychologists and cognitive scientists never expect. So I believe that there are still a lot of cases. I believe there are also some other similar research also talking about this, that there are something large language model already know and learned beyond what we know and what we learned. But we're actually doing that every day. So I believe this is kind of a fair judgment that you can say, yes, large language model can somehow really replicate human bias, cognitive bias, or cognitive effects, uh, whatever expression model, or it can be specifically fine-tuned on the data set.
I guess to kind of build on that, what is the most counterintuitive finding from your work on AI and human decision making?
I'm sorry for that question.
Oh, sorry. What is the most like counterintuitive finding from your work on AI and like human decision making?
Oh, yeah. So let me think about this. So okay, so one of the maybe it's a little bit too specific, but one of the most paper I was working on is that we find that some cognitive models are really beautiful theories um, that they can have very strong, powerful predictive performance. So I talk about this. Maybe I should elaborate with some background. So um, in machine learning, for example, in machine learning, generally, for example, if you want to train a model, our general conclusion is that if your model has, for example, 3 parameters or 4 parameters, then if you want the model to perform very well, so you should better include much more training data set, much more data points than the number of parameters, or you are likely fail to train the model very well and it's likely to fail, likely to generalize. But in our experiment, we just find that with only one example, and we train a cognitive model just like prospect theory model in human risky decision making. It was a beautiful theory, but we only have one data point. So according to the general machine learning theory, we should expect it fails very hard. But surprisingly, we just find the model performs very well even with just one data point, and it can accurately generalize to the other unseen scenarios that's with the same participant that they never seen before, but it can predict still very accurately. So we're thinking about why, because it's kind of like this kind of models are really constraint theory driven, and of course, some scientists come up with these theories. So they already seen a lot of data set. They already have a lot of insight and thinking about the model. So it's kind of carefully designed. So I believe that we are kind of underestimating the kind of human input in the designing of theories that can really be powerful because if you just regard humans as kind of large language models, they are also keep training, keep updating their knowledge every day, and keep thinking every day. So yeah, I think it's kind of most counterintuitive part that uh, some human theories, does not generally fit into the machine learning models conclusion we typically think.
Yeah, I see. So I guess now we can transition more into like advice for others who are kind of more interested in this field, maybe considering this field. So I guess to start off, what are some technical skills that are key for your work? And maybe also what are some soft skills that you should probably have?
Oh yeah. So I believe for me, I would start to soft skills. So soft skills for me, I think my most care about is about first of all, you should be passionate about what you're doing. So this is very important in the academic research. So it's not about you should stick to one of the interests for your whole life. That's not true. But you should keep passionate. You should keep thinking. Passionate means everything that you do the research. And also, I think communication and information seeking, it's kind of two different. Communicating means you talk to different people, but information seeking is more like you search information, you gather a lot of stuff, whether you want to find a super suitable lab or whether you want to find suitable collaborator or do some literate research. These two soft skills are also very important. And then it comes to hard skills. So generally, I think with those soft skills, you know what you are doing. So what you should do. So the hard skill actually depends on what kind of research you are doing. So for me, I have some machine learning background, so I have to know something about machine learning theories or maybe just simple cases of applying to how to apply them, how to use them, and also some math background, maybe just some basic linear algebra or maybe just calculus, probability theory. So it's kind of a maybe undergraduate level course. And also you should know some specifically for me, I know NLP or maybe large language model. So it's more about depending on what kind of topics you are working on. But again, I just want to rephrase that. So I always keep learning. So even at the fourth year, I still learn to gain some new skills because the field is getting developed very rapidly. But I think for the only unchanging things you should always keep passionate about what you're doing and keep thinking, keep seeking more information, keep talking, and I think that's the most important.
Okay. Yeah. So I guess for this is more specifically for high school students, but what advice would you give high schoolers who are interested in psychology and maybe like machine learning, I guess, and AI research? What advice would you give them? And this could also include like courses that they should take or like side projects they should probably look into.
Oh, yeah, that's a very good question. So for high schoolers, I do think knowing some more about each of the field is very important. Um, Indeed, cognitive science, AI, neuroscience, and even machine learning, they are not separated. As I said before, that in the early history, they're just coming from the same common group of people. So they just kind of getting some diverse interests. Some are more interested in machines, some are more interested in humans, some are more interested in functions, while some others are more interested in the implementation, maybe just our brains. So I guess there's no wrong answer that what you should be interested in, but it is always recommended that you know something about the history, a little bit history about how the CoCoSci just come to today, and including AI, and probably you will know something you're really interested in and something you are not really interested. Yeah, so for me, it's just like revisit the history, just getting exposed to different fields, maybe at a superficial level, and try to just get some attempts.
Okay. So I'm assuming you've read a lot of papers and books. So I guess what is like a must-read paper or book for someone who's interested? This could be, I guess, like paper, like research papers too. So
Yeah, maybe I can recommend a book for high schoolers. So I think one of the book is very interesting is by Tom Griffiths called Algorithms to Live By. It's just a book. There's some formula in there, but it's not a research article. It's just like a kind of scientific books that can help you understand uh, in computers with some algorithms. But actually, our humans use a lot of algorithms in our daily life, decisions, predictions, whatever, uh, as well. So I think that's kind of inspiration books that help you to understand what kind of things that I am doing right now, but it's something related, but it's more general and more suitable for those who even does not have a research background in this field.
Okay, yeah. So let's kind of conclude what is your maybe dream project? Maybe exists or still doesn't exist in this field.
I'm sorry, so I didn't hear the last
So
question.
what is your like dream project that already exist or maybe like not exist yet in this
Oh,
field?
you mean the project I insist,
No, like your dream project.
I train project?
Yeah, like any if you could do anything, what would you do in
Oh,
this
so
field?
the dream project.
Mhm.
Okay. So actually, I'm thinking about I actually try to initialize that currently, but I would like to share some of my thoughts here. So as I'm working on the intersection between AI and CoCoSci, I just realized a common problem in both fields that when we do a lot of stuff, we have a lot of progress in prediction, but when we talk about understanding, it's just really messing up a lot of terms, a lot of terms, a lot of perspectives. You know, when we say how could you claim that you understand human mind, or how could you claim you can understand model, what is the model is thinking, what the model is doing? So there are a lot of different answers that are kind of at different levels. So for me, what I want to do is trying to use a unifying framework that I finally want to somehow find a way that we can translate the neural network computations into some natural languages that can be directly transferable to our human beings. One of the easiest application I can come up with is just like, AlphaGo is very powerful in the chess playing, in the board games. But unfortunately, even the best world board game players, professional players, they don't even understand what AlphaGo is doing to make the guess. But the reason is very simple because AlphaGo is trying to make a lot of probabilities computations, which is already beyond our understanding. But if someone can just like AlphaGo can tell you something, the strategy, the abstraction, the thoughts they're thinking about when they make a move, and teach the kind of tricks to the human players, so they can learn that and they can play better, especially than the best performance currently. So what I'm thinking about is whether we can build a kind of unifying language system that we can bridge the neural network computation, whether the neural network model itself is an advanced model or maybe it's a large language model, to the human understandable natural languages. And if we can really do that, I believe our understanding toward complex systems will come into a new level. Yeah,
Okay, so yeah, that sounds really impressive. So I guess we can kind of conclude now. So thank you so much for sharing your insights today. It's very cool to hear how, you kind of combine AI and cognitive science to, especially in your projects, to better understand the human mind and have like predictions and everything. So I'm very excited to see where, your research and everything you've done so far takes you next. So
yeah. Well,
thank you
thank you
so
so
much.
much for having me. I was always happy to share this kind of something I already knew in my experiences. Yeah.
Okay, thank you.